before we get there, we have today's speaker, and so I want to introduce Fred Lamb. Let me just say a few things before we get him out here. Fred came here in 1972, and he is the Brandon Monica Fortner Endowed Chair in Theoretical Astrophysics. He's going to tell us today about missile defense systems, but in fact his day job, if you will, is theoretical astrophysics, and he's an expert on things like X-ray bursts from neutron stars. So in fact, maybe in the beginning, Fred could tell us a little bit about how you got from astrophysics into things like defense, nuclear missile defense, just briefly, if you would. We'd appreciate that. Because what he's been doing most recently is chairing an American Physical Society study panel on the feasibility of a missile defense system. This is a national panel. Fred was one of the chairs of this panel. And just this week, the panel was presented the Leo Szilard Lectureship Award. And I want to read you what that means to win this award. It's a very prestigious award. The award is to recognize outstanding accomplishments by physicists in promoting the use of physics for the benefit of society in such areas as environment, arms control, and science policy. The lecture format is intended to increase the visibility of those who have promoted these use of physics for the benefit of society. So Fred is here today to tell us some about missile defense. It's a real honor, and one more thing I just want to say before I get him out here, just to embarrass him a little bit more. Fred is one of the most fascinating people I've ever met in my life. I've never had a dull conversation with him, and I know this is going to be a very exciting talk. Please join me in welcoming Professor Fred Lamb.
Thank you very much, Kevin. And also thank all of you for coming in today on such a nice Saturday morning to talk about this subject. As Kevin said, my day job concerns astrophysics, which is really my first love, and I work on these other subjects as a volunteer for public benefit. I first encountered the question of nuclear weapons when I was a young teenager. I was interested in science from a very young age, and during the 1961 Berlin crisis between the United States and the Soviet Union, both sides were threatening to use nuclear weapons, and it looked like it might actually happen, so the government was handing out to everybody pamphlets on how to dig bomb shelters in the backyards and encouraging everybody to do that. And people were terrified. There was a huge effort. And my parents said, "Son, you know something about science. Would you please tell us whether we should dig a hole in the backyard?" So I went down to the library and I started reading in some books on the effects of nuclear weapons in particular, because government report Gladstone and Dolan, and it was really horrifying. So after studying that, I came back and said, I think our best bet is to prevent this from ever happening. And so that's really been the source of my interest, and that's been my approach, which I haven't wavered to this day. But I put that aside and did lots of other things for a while. But the physics community in general in the United States is very public-spirited and very much interested in the interactions of science in general and physics in particular. With areas I know young people feel that they're seeing askance at them if they spend some time in encouragement for encouraging interdisciplinary work, but also for being concerned with public policy questions and with society. So when I came here, there was already, many of the physicists were members of the Federation of American Scientists, which was the organization founded by the original participants in the Manhattan Project in an effort, first of all, to make sure that nuclear weapons and nuclear power was controlled by the civilian side of the government and not the military, but it went on to be a bit fighting for fairly safe policies on nuclear weapons and arms control. So there were already people here. So I actually got more seriously involved in 1980 when I decided that maybe things were going a bit off the rails, and that everybody who could help probably should think about trying to. So that's how I got started. The next year, together with Larry Smart, who's formerly the director of NCSA, we formed the Illinois Alliance to Prevent Nuclear War, which had a one-point program, which I was stating. And so we tried to provide information and venues for people to think about this problem and to do things. So that's how I got involved. Okay. So what I'd like to talk about is, could a defense against intercontinental missiles work? And for myself, I've given many talks on astrophysics in these Saturday morning. I felt to have a chance to have a conversation with all of you about this subject, because I think it's a very important subject. It's a subject that that really we could not think of something that is more relevant to the future of our country and to our security than to think carefully about it. So thank you for coming and being with you talking about it. So I really want to encourage you to think of this as a conversation. So one of the things I wanted to say to kind of provide a framework and so on, but I would love it if we could have a conversation as I go along, or anything that you want to say, just hold up your hand or speak out, and this would be exactly what I would want. Okay? So any questions so far?
The Joint Association for the Prevention of Nuclear War that you mentioned, is there any successor organization? I've looked on the web, and apparently that organization isn't around anymore.
Yes, it lasted for about 10 or 12 years, but I think that locally, as far as I know, there isn't any organization, but there are national organizations are carrying on that tradition. The Federation of American Scientists that I mentioned continues that tradition. There's also something called the Arms Association, which is a national organization, a lot of public outreach and public interest and so on. So actually, this is a advertisement. If you look on the physics website, Physics 180, the course I teach every spring, and it has a lot of links to organizations of the kind that you're asking about on the links page. There's a wealth of other information, but in particular, there's that. Okay?
Thank you.
Great. So, this is a course that has become, it's very successful. We have to cap the enrollment. That usually happens within 2 days after enrollment is open because there's so much interest in it. But it's an intensive writing course, and we can't actually handle more than that, although we do divide it to. Okay, so I want to say why I'm interested in this subject and why I'm glad to talk with you about it. I want to just mention, to calibrate ourselves, the consequences of a nuclear attack, even just a nuclear explosion. Only nuclear weapons are considered by people who work on weapons to be truly weapons of mass destruction, and only nuclear weapons threaten the survival of our country. So to calibrate that, let me just mention that a small nuclear weapon exploding in a major city within seconds to minutes kill several 100,000 people and reduce many square miles to rubble. That would mean by a weapon of destruction almost instantaneous. It's huge by comparison with any fatalities in such a short time, and would reduce the major central part of any city to rubble. If we had a large nuclear explosion in a major city, within seconds to minutes, we've seen many millions of people dead and hundreds of them. So that's what weapons of mass destruction. And as bad as they might be, chemical and biological weapons are, by professionals, they're not considered weapons of mass destruction because they don't act so suddenly. There's a chance in the case of chemical weapons, it's very difficult to kill very many people with them. To contaminate areas, you can make maybe hundreds or large numbers, and you don't destroy the weapons. Biological weapons are more, but again, it's typically or maybe even weeks. So same sort of thing. In the past, when things like that happened, it was able to contain it. So we can't say that for sure in the future, but it's an order when we come to a nuclear weapon. The blink will wipe out the center of hundreds of thousands of people. So that next aspect, you may, if you've been programs before, you may have noticed they are controversial. Well, I would argue seven. So, for example, if an effective defense was clearly possible with near-term technology, such as would not pen states, and also it would cause other countries to use, that would end up decreasing our security as we build them. And if it would not distract us from taking other, that would be more effective in increasing U.S. security. Unfortunately, these conditions have never been met so far. We've been working on building, as I've come to admit, missile defense systems for more than 50 years. It's a really hard problem, and we haven't been able to solve it now. So that's the first point. It's very expensive because it is so challenging, even for systems that don't work. And it's not like going to the moon. When you go to the moon doesn't say, ooh, those humans are thinking of coming here, and starts moving in a different place. But adversaries, human adversaries, take responsive action to counter what you're doing. That's a fundamentally different situation. And we can see that, we have already, in my judgment, seriously distracted from taking many other much more important measures for our security by the concentration on missile defense, which no chance of working in the near term and has consumed hundreds of billions of dollars plan is, for the last 4 or 5 years, we've been spending more than $10 billion per year. And the plan is to double that within the next couple of years to $20 billion per year. I think there are probably better ways that I'll come back to that we might increase our security. One of the reasons why controversial is because anti-ballistic missile programs have so often been used for purposes other than defending against missiles. The examples are as bargaining chips, which is what was done for the system I'm about to talk about, the Safeguard system in arms control negotiations, $5 billion. I think that's a pretty valuable chip. Sometimes used to destroy hated arms control agreements, which may be hated for ideological or political reasons, to support defense contractors, to win political advantage, to create what I would judge would be a false sense of security. And it's always been so. It's such an emotional subject that almost nobody comes to it without strong emotions and bias. And I'll just give you a historical example that talks about how these sort of things come about. Typically, always, it's the president of the States is very deeply entangled and very much involved in missile defense. An example, the first we considered deploying, we were working for 30 years before that, but actually deploying a missile defense system was in early 1968. And the Congress and missile contractors were saying publicly and arguing we could defeat an enemy missile and we should build it now. So in 1968, President Johnson, his Secretary of Defense, was telling him, this doesn't actually have a chance of working. I'm getting all this input from everybody, so we called into the characters the President, Undersecretary of Defense for Research and Engineering, the person who's in technology in the Defense Department, that was serving under him. And every single Secretary of Defense and Undersecretary who had ever served in the government, and he asked them one question: will this work? And around the room asked them, every single one of them said, Mr. President, this will not work. If we have money, we should be spending on other things. And 2 days later, conference and announced, this is the kind of situation we confront these kinds of issues. So, I'm talking about missile defense. Missiles pose greater threat to the security of the United States than missiles universally people who are about the subject. So these are statements taken, these are quotations from the unclassified of the 1999-2001 National Intelligence Estimates of ballistic missile threat through 2015. Even in 1999, so 2 years before 11, the CIA official assessment, and this part was public, several countries are capable of to launch short-range missiles, medium-range missiles, or land attack cruise missiles from forward-based ships or other platforms like barges off our shores. Some may be able to develop such systems before 2015. These are not long-range things that have ranges of tens of miles or 50, if it's very relevant. U.S. territory is more likely to be attacked with chemical, biological, radiological, or nuclear materials from non-missile delivery means, most likely from terrorists, than by missiles, primarily because non-missile delivery means are less costly, easier to acquire, more reliable and accurate, and they can also be used, which means that if you are attacked by those kind of things, you can't certainly immediately figure out who it is who attacked you. So retaliation is a problem. Okay. So now I'm going to, before I go to the technology, just alert you that although as Americans and I as a scientist and technical fixes, it's just the reality of the real world. There isn't a technical fix for every problem, it turns out. We should, before I descend into technology, remind ourselves that there are other approaches which can work better, and they often do. So for reducing the threat of ballistic missiles, now zero out possible approaches seeking friendly missions. I always remind students that at least I don't lay awake at night worrying about the intercontinental range missiles that Britain has that destroy our country in 30 minutes. And the reason is because of our relationship with it. And so there are other factors besides just the capability. Attempt deployment missiles, that has been successful on many occasions in the past. And attempting to destroy threatening missiles on the ground, that's actually what would happen if we were seeing somebody setting up a missile and thought they were going to attack. We have not dream of waiting to use what little or non-existent defense capability you have, we would destroy it in bad ground. And if we saw that happening, and you were, what looked like launch of a nuclear missile against us, that's what we should do. We shouldn't wait and say, I would not tell the president, Mr. President, we're working on this next thing, and so, when we see the damn thing coming at us, then, we shot at it. Okay? No, I would say, let's go in with our land attack missiles and destroy it right now. And so, that's what professionals call a preemptive attack. When an attack is in, it's imminent, you have only minutes or hours to respond, and there's no alternative. That's called preemptive attack. Anything else is preventive war. Okay. So what we're going to talk about now is something that is a very chancy business at best. Never been able to do it. Nobody's had to do it. But that is to have to destroy attacking missiles as well. So that's what we're about for most of the rest of this period. So one of the things I want to do is first give a brief history of missile defense. I'm focusing on United efforts and primarily against long-range missiles. And the main components of the current effort put in place beginning in the late 1990s and augmented until today. And the main components are ground and sea-based rocket interceptors for midcourse defense. I'll explain these terms in a minute. And then a proposal to pursue, and actually, many billions of dollars being spent already on something called boost-based. So I'll back in to ask what should be the role of missile defense, and I'd be happy to have people from the audience come in and contribute to this discussion, because it's something we really have to, as a society, as a country, discuss and think about, I believe, much carefully than we have today. Okay, so a couple words about the history of missile defense. The thing I want to say, if you read the newspapers or listen to, you might think that serious work on missile defense just began last year. Or you might think that it just began at the end of the Clinton administration. Or, even more likely, somebody might say that it just began with Reagan and Star Wars. This is nonsense. We've been working hard on this for 55 years. And we actually deployed the system in the 1970s, the only one we ever actually deployed. 1970, we were working and deploying it. So this is just not true. And it gives the wrong impression that somehow everything's changed and we have some kind of a solution now that we didn't work on before or we just weren't trying to do. So here's just a rogues gallery of some of these systems. Nike Zeus of the 1950s. Nike X was the improved Nike Zeus because this really worked. Sentinel was proposed by President Johnson. Sentinel was supposed to defend cities. Okay? But that was 1968. When President Nixon was elected later that year and came into office, it was pretty obvious this had no chance of working. What he said was, let's change the name. Okay. So we'll have something called the Safeguard System instead. Everything's the same except the purpose. He said something which actually really relevant. He said it's actually much easier, though very, very difficult, to defend missiles in hardened concrete silos than people. So he repointed the defense system to defend ballistic missiles, ours. Okay? Actually, that's where the term ballistic missile defense comes from. The original meaning is the same. It was the defense of ballistic missiles. Okay, it's been twisted and contorted and so on, but that's not what it's in. So then we had the Safeguard system, which was deployed. The DPALS, which was a very small system, which was concept, worked on in 1991. We've never not been, and then Clinton administration pushed into doing something in the 1990s, and what they were doing was with ground-based rocket intercept, Midcourse Intercept, and that's what it was called in 1997 to 2001. When the current administration came in, they banned, I'm not kidding, they banned use of the term national. They said this was reminiscent of the Clinton administration. So I've been in meetings with defense experts where I talked about the foundation against ballistic missiles. I've been publicly casted by officials in the Missile Defense Agency said, you should speak like that. We don't talk about national missile defense anymore. So even at the technical level, it gets incredibly ideological and political. Okay, so let me just tell you about the Safeguard system. It was developed and deployed. This movie will show you what it looks like now, but it was developed more than $5 billion spent on this one defense site, which is in North Dakota. Oops, sorry.
The carcass of the only weapon the United States ever lies scattered across the North Prairie. It was called Safeguard. It was ordered by Richard Nixon. Nuclear-tipped interceptors would blow up Soviet rockets heading toward U.S. missile sites. The Pentagon secretly warned that these would be able to overwhelm it. Safeguard would quickly become obsolete. In a secret memo, Nixon was told the lead contractor wants a business because the system cannot adequately perform the mission assigned it. The day after Safeguard became operational, Congress voted to shut it down. The system lasted 133 days, $25 billion.
I call upon
Okay. That's the system we deploy. It's still there and visited. It's quite interesting. I want to ask the question then, why is there renewed interest in ASIC today? And there's several reasons. One of the main reasons that isn't talked about publicly, but actually driving a lot of the work on it, is concern about a Chinese ballistic missiles. Then more publicly, we heard about the possibility of nuclear missiles. I just want to emphasize that there are the Chinese, about a dozen that could reach the United States. We exist in building a missile defense system, they'll easily deploy 1,000. They plan to do it, they persist. So that's an example of the months, okay? And I tell you that in most experts with upwards shape with a solid propellant Chinese missiles pointed at us that could be fired on a moment's notice, 12 antiquated liquid propellant missiles, may or may not work well. But we're going to make them do it without cooperation. North Korean and Iranian long-range missiles, so both are working on missiles. I'm very absolutely clear that, hypothetically, the missiles that they have tested are about 8 tons. And I don't know how good your geography is, but even I know that Iran is much further away than that. It's like 12,000 kilometers, about 5,000, 6,000 miles, and North Korea is a similar distance. So, yes, they're working, we should be concerned, but we have time. We don't have to do something in a rush. We just wait to do this. And trying to deploy a system that we don't have confidence in may be the wrong approach, because it's likely to drive into other things which will make it even more difficult. I mean, that's the whole history of the subject. Again, this the most problematic approach to this historically. It's never been possible to do that. And sometimes the other approaches have actually worked. Okay. So, again, this is probably what I don't want to get, that this is the most of every professional's assessment. Sometimes, if you just have it enough, then people come away with the idea that, my goodness, he spent the whole morning talking about this, this must be the really most serious threat. No, I was out about this. We're spending billions and billions and billions. Pretty soon we'll be spending real money and, separate. Okay, so here's the phase that ballistic missile flight. Starting with the boost phase, which is for the time when the rocket motor, which lasts, at most 3 to 4 minutes. And then the rocket motor is shut down. Then even before, certainly by that point, the warheads will be released. And this is an example of such a one. It's had a difficult time. It went through the rocket test. But this is exactly the size. It's a real-life scale model of the so-called city buster, 335 kilotons, 25 times the power of the bombs that destroyed Hiroshima and Nagasaki. And most of this is using electronics and so on. To develop this cost more than $20 billion. Okay? And the physics package in here is only that one, and it's about that big around. That's why it's so expensive. Okay? So the thing I'm going to come back to is it's not trivial to make such a thing. So if you have built some kind of nuclear bomb that might work, and you built a rocket, you aren't there yet. You have to get to the point. This, this is so bad and everything, is it re-entered at hypersonic velocities, where it was heated to temperatures of tens of thousands of degrees. So that's the challenge that anyone wanting to build these sorts of things has to face. So then in the midcourse phase, which lasts 20 or 30 minutes, basically the warhead is just falling on the arc in space. And they travel fairly fast, 15,000 miles an hour, and intercepting them requires defeating points, things that look like warheads that aren't, and if there are multiple warheads, you have to get on. Then the last 30 to 40 seconds is called terminal phase or re-entry phase. And that's when the warhead re-enters the Earth's atmosphere. So right now, terminal phase is the only thing we actually ever have, and it hasn't been very successful, but we're working on that still. So that system and the Patriot, we're spending $1 billion in this year on those systems. Okay. Patriot, unfortunately, bad experience in the first one, where there's only one documented intercept out of the hundreds of countries. It's not what you got told in evening news during the war, that reality. So we have some work to do. Midcourse Intercept with land and sea-based rockets. There's 3 ground-based Midcourse sites that are planned. Right now, there's 4 holes in the ground in Alaska, and one of them has a missile interceptor in it. Never been tested. The others that they're relatively near term on the coast of California, on the coast. And then they're talking about also using ships for the same purpose, and this portable mobile ground-based interceptor rocket system. But these are not particularly capable. These haven't been tested at all. If they work as they're supposed to, they'd be much more capable. Intercept is the new boy or girl on the and it has 3 components: the airborne layout, 800 million balloon, many billions in future years if they continue it, or kinetic energy interceptors, 100 million in FY04, and this was meant to be more like 500 million this year, but the study that I led concluded that the team there for that and others supported our they didn't make $500 million for this year. They stayed at 100 million, which is what it's been every year for several years. Tom said the technology is too immature. We shouldn't make such a commitment. And then the other possibility is space-based rockets, which we concluded, and I'll talk about, where it was really not feasible for the foreseeable future, and it was actually canceled in August of, actually, I said FY04, but its calendar year was 03. And the head of the Boost Space Missile Defense Agency said publicly, he said, the scientists who looked at this and our contractors tell us this is going to be impossible for the foreseeable future. So I'm canceling this program. It's a complete waste of money. Yeah. But he went on to say there are a lot of people in the White House who really want this kind of system. If they make me do it, I'll have to do it. Now, some of us were thinking, my goodness, this is professional candidate, but how long is this guy going to be around? Well, he's still. So, however, a few months ago, they announced that they're restarting the program. This is how it goes. Okay, so let me talk about Midcourse defense. During that previous following part.
Now, teams from the biggest factors in the defense business would work to develop what the president had ordered. A system to shoot down missiles during the time it travels through space. A kill vehicle, a miniaturized package of sensors, computers, and would zoom up 140 miles, home in on the enemy warhead during the mid-course of its flight, and smash it to bits through the sheer force of the collision. The Pentagon calls it hit to kill.
So that's actually the preferred method for intercepting warheads and even missiles. The Safeguard system that I showed you earlier, I didn't mention, but the only way it had a chance of actually destroying anything was if it had a 50 megaton warhead on the tip of the interceptor. Okay, that's bigger than the largest warheads we ever put on our ICBMs. And the reason is because you have to have a big explosion when you miss, to hit. So there's some small problems with that, though, which is part of the reason why it was actually discontinued, because explosions like that, which would have to occur right above the big cities, have some unfortunate side effects. So let me talk about the defense system. The plan system is to have 6 interceptors deployed soon, which probably maybe 4 even by the end of the year. The president, when he came into office, said we will have a defense system that will protect us by September 30th of 2004. So we didn't quite make it, but it will be announced as operational and effective within a few weeks. Okay. So the reality is somewhat different. But I can tell you, if you go around to the contractors, like Boeing is a lead contractor, they had a bad experience. They were supposed to take an off-the-shelf rocket for this, and they were chosen. We had a rocket that was very similar. They were never able to. So after 2.5 years of delay, the Defense Department said, "The heck with this," and they actually asked Lockheed. They didn't know coming, but they said, "Lockheed, we've got to give you a lot of money to see if you can build a new interceptor." So that's where the interceptors stand. But in all these contractors, if you go into the lobby, you know, they have these huge digital clocks, not like these little things, like that panel up there. It shows the days, hours, minutes, and seconds until September 30th, 2004, when the system was to go live. Well, it didn't quite happen, but you know, that was the focus. The president said we'll have it by then, so that's what everything is focused toward. It requires new radars, which we don't have, but you know, we've replaced them in tests by having blinking beacons of light and radio signals and stuff to tell the interceptors where to go. So there's been almost no testing. And this again is very typical of missile defense. There have been pilot tests. So by unrealistic, I mean that they prepare for months or years in advance. The trajectory the target's going to fly is very rigidly controlled. The defense knows the precise instant the target missile will be launched, the precise path it will follow, exactly what it looks like, exactly what the target warheads look like, and what they will be doing. Okay? And still, and also, by the way, the warheads have beacons sending out radio signals to tell the interceptor, "Here I am, come get me." You know, we don't count on the enemy doing that. So, it's not crazy to do this. This is how you start out with any challenging technology. What, in my judgment, is crazy about is to pretend with an active system when this is what we're doing. And because of the pretense, we're actually not doing the things we need to do if we're ever to get there. So, for example, this is also typical. The interceptors we used so far are not the actual interceptors, and they're much slower than the ones that we'll have to use. And the result is the closing velocity is more like this, so it gives the system much more time to figure out what to do. In the reality, it's going to go, and we don't have the interceptor, so we're just testing at low speed. It's fine, but that's not intent. The required interceptors have not been fielded or tested. The required radar and satellite capabilities will not know until September 2005 or later. So the last test in 2002 failed. At that point, testing was suspended until after the 2004 presidential election. So I'm told that's a purely technical decision, but it wasn't phased that way. It's like this. Okay. So some of the challenges of Midcourse Intercept. You could launch multiple warheads or dozens of biological submunitions, little hardened tin brass canister. And if so many warheads coming at you, it's easy for the defense to become over. Okay, and that's what was, typically done in theater defense situations. Each ICBM could launch counters. That's what are called penetrations. Things, gizmos that are designed to allow the warheads to penetrate the defense and reach the target. And examples include large numbers of lightweight decoys. Decoys, something that looks exactly from the outside like a warhead, but it's not. And the warhead is something that either looks like this, or it's actually something that would be different. And outside the atmosphere, these would be difficult to distinguish from warheads because there's no egg, and everything falls in the same way. Okay, so let's see. I have some comments by some people.
Stephen Weinberg has long consulted with the government on defense matters.
We won't know what the offense will be. We may know the nature of the nuclear warhead, but we will not know what other things are sent along with the warhead in the form of decoys that will exhaust our defenses. I don't know how that problem can ever be solved.
The simplest decoys, what the Pentagon calls counters, are mylar balloons, like those sold in supermarkets.
Balloon should be a big mylar balloon, maybe 10 feet in diameter, coated out, all packed up tight, knitted in flight. By empty party balloons the same size. The aluminum foil keeps the heat that's inside from getting out. You can't look into them visible light. They look the same to the interceptor. They look the same to radar. It doesn't make any difference. One weighs 1,000 pounds and the other one weighs 10 pounds. As Galileo made it, if you have a feather and they led up with the same speed in a vacuum. And that's what we have out there, a lot of vacuum.
Shooting down an ICBM is like hitting a hole in one when the hole on the green is going 15,000 miles an hour.
Now that's the voice of Philip Coyle, who was the head of the Pentagon's Office of Operational Testing and Evaluation for 8 years, and was in charge of assessing the performance and the tests that were being conducted. He went on to say that the real situation is trying to hit a hole in one when the hole is moving at 15,000 miles an hour, and there are 100 other holes that don't count, that are moving around on the green. That's it. It is quite hard. So it's not really quite, we're turning out to the question of basic defense, which is the and that basically trying to intercept while the motor is still burning. So let me just take a second to mention, why is there interest in new space intercept? Well, is because Midcourse so darn hard. So it's natural if something's really, really hard and you think it's important to do something like that, then you start looking at alternatives. And this alternative first surfaced in the op-ed page, never any technical analysis. In the beginning, it was just something that people thought sounded like a possibility. But that's what my study group looked at, did the first real technical. It's all online, some short executive orders, nearly 500, very small. It has had a big influence because partly it was so thorough, so careful. First thing that had ever been done on this subject. Well, whose space has been easier, and in some ways it is, but in some ways it's harder. So, even on the website today of the Missile Defense Agency and the advocates also, they describe the ICBM as slowly moving fragile. Well, this is not quite accurate because they are very fragile. But it was watched a rocket to take off. When it's sitting on the launch pad, it's moving very slowly. Okay, and when it first lifts off, it's moving. But hey, if you're standing there, you can rifle. Okay, but that's not what we're going to do. We're planning to stand 1,000 miles away and shoot it. That rocket is not going to be at the launch pad, and it's not going to be moving slowly by the time our interceptor gets there. It's going to be moving just as fast as the warhead. Okay, so this is really misleading. ICBMs have bright exhaust plumes that are easy to track. This is very true. I mean, one of the problems in the Midcourse, my goodness, there's these little, this looks big here, but when you put it out in space, there's a lot of space out in space. So, it's really hard to find, there's all these decoys and stuff like that you have to worry about. So, the rocket plume you seem to be, when it takes off, it's, bright, dazzling plume and everything. So, from far away, it's really easy to see and to track and to go toward. The thing that they often don't mention, though, is that hitting the plume doesn't actually do anything. Okay? So, in fact, the plume becomes a serious problem when you're trying to hit the missile body, because it's like trying to find the bumper on a car when the headlights are pointed right at you. It's dazzling. And actually, we cannot usually know where the plume is in relation to what's called the hard body, and so on. So actually, it's great from 1,000 miles away, but by the time you get to within 100 miles, it's a serious problem which is unsolved. Now, our study group, we thought at first, the technical people like myself and others thought this was a showstopper. But we actually worked hard on the problem and came up with an alternative approach, which involved using light radar type signals and pulse coding and so on to get over this problem. So this is the kind of solution that you find on paper, which looks like it might work, but of course nothing was ever built, nothing was begun to be tested, but we decided it wasn't, but it's not solved. An ICBM deploys its warheads. So that makes it easier. You only have one thing to hit. But the problem is that it'll deploy its warheads within 2.5 or 3 minutes after that screening to get there by that time from far away. We don't have any rockets, we've never built any rockets that can travel that far, that fast. It's not so clear how easy it will be, because it's very easy for the offense. Pretend this is my little rocket. So it's in powered flight, so it's dazzling plume and everything, and you're coming up on it. You don't know if the warhead's still there. The typical, simplest thing you can do for low-tech people, that's what we did for the Polaris system, was to just put a little tube that was hollow on the missile, tipped out this side, powering forward. You just release it, and it slides out the tube and goes away from the missile, and then it comes out spinning. Beautiful. Then the missile goes, you can't tell from more than 100 feet away what's happening there. So, perfect decoy. It looks like a missile that's in power flight, because it is. Okay? So, it came out difficult. So people talk about, well, gee, you know, it might take them 10 minutes to deploy the warhead and so on. These people don't know about the technology. We never did that. There's no reason to. It's much better, it's easier, it's simpler, it's low tech to do something that's more difficult for the defense. So, they also say boost phase would reduce the challenge faced by the midcourse because the boost layer would eliminate some of the targets, so the midcourse would have fewer targets to worry about. This is certainly true in principle, but it's too easy to say if you don't think about it, because what happens when you have a successful boost phase intercept? You create an enormous debris cloud. Many of the pieces of debris just look like decoys and countermeasures and so on. So, you know, nobody's ever done, there's no analysis of this at all by anybody that's really at all serious. So the question is, I mean, it could be that having a boost phase layer makes the midcourse even more difficult. We don't know. So, but it's certainly not true to say that it makes it easier. That's just unjustified. Okay. Here are some of the key issues for boost phase intercept. I mentioned some of them. The boost phases are very short. 4 minutes for liquid propellant missiles, 3 minutes for solid. And the defense has little time to decide whether to fire. So, for example, you'd have to fire before you knew whether it was a peaceful space launch or a rocket attack. You have no choice. You have to basically say, you move, we shoot. Okay? Because otherwise you won't have a prayer of giving it a time. And there's other aspects too. I mean, the command and control issues are quite serious. Would you do a strategic attack to some colonel in a bunker in the field? I mean, we've done that during crises during the Cold War, but it was not a happy situation. And that would be if there was an incoming attack that we could prove. You know, here we might not know whether it was a peaceful space launch or not. The geographical constraints require very high interceptor speed because you have only a couple of minutes and you have to go a long way. People sometimes, you see diagrams where, you know, the interceptor is supposed to hit the launch pad. Well, I'm sorry, the missile isn't there anymore. Okay? The missile's flown out, you know, 1,000 kilometers or 800 miles downrange now. That's when you have to jet. And in North Korea, that's a big difference because the launch pad in Korea is a small plane. So you could sit off the coast and pick off things on the launch pad fairly quickly. But that's not where you're going to have to intercept. I'll show you. You have to get deep into China to have a chance. A successful intercept is unlikely to destroy the warheads. It could, but it's unlikely. And consequently, a successful intercept could cause live nuclear warheads to attack the territory of the United States or U.S. friends and allies. So this is referred to in the trade as the shortfall management problem. So shortfall is what you want. You do not want the nuclear warhead to fall on the target. That's great, but you also don't want it to fall on another city. And that's not so easy to do, to prevent. Now, there's much more territory of any country, for the most part, that doesn't have big cities on it, but this is a risk that nobody really wants to take. Okay, so the interceptor's final stage is called the kill vehicle, for hit to kill, and it has to be able to maneuver to hit the ICBM in powered flight. And normally ICBMs, even if they're not doing evasive maneuvers, are moving very unpredictable, crazy ways. So it's a really tough problem. We thought this was also possibly a showstopper, and none of the technologies or computer guidance algorithms that we were presented could solve that problem. Okay? Now, I'm not saying we're very good. It just illustrates what we did. We actually came up with a new guidance and control algorithm, which we demonstrated by computer simulations, you know, probably would work. So that's not showing that we're brilliant. I think more it reveals how little work was done on the problem before it was put forward as a serious proposal. So, I mentioned this. So here's how global geography determines how early the ICBM must be intercepted. So here's these are ground tracks of solid propellant ICBMs out of North Korea to the continental United States. And this is not the missile flight path. This is the mark on the ground underneath it. And the numbers here are a little bit tricky, so bear with me. Just to remind you that this whole flight path takes 30 or 40 minutes. The boost phase lasts 2 or 3 minutes. So it should be clear that the boost phase ends over here. That everything, the power flight is all happening very near to the launch site. And this is where the things fall after the power flight is over. But it's interesting to know how you would have to intercept the rocket in order to prevent its warhead explode on the United States. And this kind of chart helps with that. So these numbers tell you how many seconds you would have to intercept in order to prevent the warhead from reaching a certain point. So for example, here's the total burn time is 170 seconds. So that's what you need to get to Crawford. But if you cut it off at 140 seconds, then, it would still reach Alaska. That's 25 seconds earlier. So to be able to defend Alaska, you have to get there before 140 seconds. Okay? And seconds matter. You're just completely under the gun from the beginning to the end. 25 seconds is years in this business. It's much worse. So one of the things I warn you is, it's not impossible to do this. There's no law of physics that says you can't do it. But what you see is people talking about they always use 170 seconds, or they use 240 seconds. Because that's the total burn time if you let the rocket burn until it burns out of fuel. It's not relevant. The question is, how long does it have to burn before the warheads have enough momentum to fall on the U.S.? If you wait till after that, you're cooked. You have to get it before that. Well, here's the same kind of argument out of Iran. So, this shows the close-in geography and why no analysis before ours did any analysis of the geography. They just talked about missile speeds and ranges and stuff. The geography is really crucial for the reason I just said, but close-in also. So here's a liquid-propelled ICBM facing a 5 km/s interceptor, which is pretty fast. And so coming out of North Korea from the launch site in the hills here, headed to Boston. I have a lot of friends in Boston. We picked this for other reasons, but actually the co-chair of the study group comes from Boston, so it wasn't anything about Boston that we kind of make them feel about. But so here's the launch site. This is, you have to reach and intercept it by this X in order to prevent it from reaching Boston. Okay? So, hey, this is China, okay? So sitting here off North Korea, or even here, this looks pretty easy, but it's not going to cut it. You have to get there, which is hundreds of 500 kilometers further away. And there's, if you want to put it on a ship, a common recommendation, well, you don't have any space really. This is all China. This is Russia. If the Chinese would cooperate and allow us to put an interceptor base right there, it would really help. But I don't think we can count on it. Here shows what happens if you have the same ICBM and a somewhat faster interceptor. Now this interceptor, these are all computer models and computer simulations. This would fly as fast as an ICBM, and no interceptor that big or fast has ever been built. And you see what happens though, if you get bigger, more speed, it helps the defense, because the circle that's smaller here now expands, and now there's a little bit of sea room for, say, ship-based interceptor. So on the defense side, it's speed that you really want, you have to have. But this shows what happens when you go to a solid propellant target missile instead of a slow lumbering liquid propellant. So this is a first-generation solid propellant ICBM coming out of North Korea, and against the fast interceptor I just talked about, you're completely out of luck. You're totally out of luck. Now, people said, oh, gee, well, it's true that going to Fairbanks, it doesn't have to burn very well, which is why the X here is so close to the launch site. But if they have to go to Boston, they have to keep burning for a longer time, and you have more time to get there. But you have to look at the geography. The trajectory to Boston goes way inland compared to the trajectory to Alaska, and that rotates the whole pattern inland, so you actually don't win. Okay? You really have to do the analysis. Just words, and spreadsheets are not spreadsheets. There's hardly any spreadsheets because of just pictures and airbrush diagrams that don't cut it. So here's Iran, and the main thing I want to emphasize here is Iran is a big country. Okay? And so consequently, if the launch site is in Iran, which if Iran is firing, it probably will be, you have to go a long way before you get there because Iran's borders are far away. So this shows for a liquid propellant ICBM, slow lumbering one coming out of Iran with a 10 kilometer per second interceptor. So this interceptor, I'll show you what it looks like in a computer model. It's times as fast as the fastest ICBMs that have ever been flown, and it has to get to that speed 5 times shorter time. Okay, so this, and it screams, and we said, okay, we'll give you a menu of possibilities, a menu of options, and we'll show you what happens in that. So you choose. You know, we have no reason to choose one or the other, so we'll just tell you. Okay, but so we said, let's build the most fastest limiting case interceptor that we could imagine. And when we showed this, we were ridiculed because they said, this is crazy, you know. But we said, look, it's not forbidden by the laws of physics, and you know, maybe some people think you could build this, and it is the limiting case. You can't do any better than that. So let's see what it says. Well, if you have a slow lumbering target missile and you're able to base it in what we refer to as unusual basings, such as Turkmenistan. I mean, unfortunately, Pakistan and Afghanistan don't help, but you know, Azerbaijan and Turkmenistan would be helpful. Both together would be even more helpful. Those are very insecure, unstable countries, and you know, it's not clear whether we would ever dream of doing that. Another place that people talk about is, you know, you can look at this and they immediately say, oh, you could put something in the Caspian Sea. True, but the Caspian Sea is landlocked. That means that any ship you put in there, you have to build there. You can't move it. The other thing is it's surrounded by countries that are hostile to the U.S. So, well, you know, we have ways of dealing with that, but it's not trivial to do it. And if you go to solid propellant ICBM, the lower 48 states, for example, you know, you have to base the interceptor base inside this football-shaped area. Hey, this is a randomized. This is the Caspian Sea. It's not easy, okay? Now, it's not impossible, but I think what happened was that people were working on Midcourse and they were sweating and bad things were happening. They kept saying, geez, you look here, it's just full of weeds. And then you look over there and it says, gee, it looks really green over there, okay? But you know, you got to walk over there and see. And when you walked over there to look at it, there's a lot of weeds there too. Okay, so this is not unusual. So this is the Minuteman III ICBM, the largest land-based one we ever, well, it's the MX, but it's very similar in size to the Minuteman. We just decided to go in the same hole. Here's the interceptors we consider. You know, this is an example of the 10 kilometer per second guy. It's twice as massive as the Minuteman III, and it's humongous. Okay, it's huge. Okay, you're not going to put that in a ship very easily. For example, you know, it have to be land-based. And even then, it's really stretching the technology tremendously to think of building and flying that. We've never done anything like that. Okay. What about space-based interceptors? The main point here is to realize some key physics. Okay. Number one, unlike what you see in many of the animations and even in some of the Defense Department briefings, if you put the satellite in orbit, it doesn't, in low Earth orbit, it doesn't stay above the place you put it. It goes around at very high speed. Okay. So if you want to be able to attack from overhead one launch site, you actually have to put up 3,000 satellites because mostly they're never going to be there. Okay? And to complicate matters, you can't put it into an orbit that just passes over that launch site because, in case you haven't noticed, the Earth rotates. But the orbits don't. They're fixed in space. So you put it into an orbit like that, and it, you know, when it's launched, it goes nicely over the launch site that you want to attack. But you know, an hour later, the launch site's rotated away. So you have to fill near-Earth space with thousands of orbits to cover. So we looked at this and we optimized everything in sight, and we found, and we looked ahead. We said, okay, here's what we could do. We think we could do. We can't do it today, but in 10 years, we might be able to do this. And we said, in 15 years, if we make the most optimistic assumptions, we might be able to do this much better. And then we looked to see what that would allow. So we found that obviously one advantage is you don't have to worry about the local geographic constraints. You're just, you know, in orbit. But on the other hand, your interceptors aren't near the intercept point either. So we found that to counter solid propellant ICBM, you would need which we think adversaries might have in another 10 years, long before we could field such a system. 1,600 interceptors would be required for a minimum massing over 2,000 metric tons. And just to put that in perspective, to put that up over a period of 3 to 4 years would require us to have 5 to 10 times more space launch capability than we have today. And that's throwing everything at it. Shuttles, which we don't have now. If we have them, we counted them. All the large expendable rockets, all the rockets, everything. We added it all up, and we still 5 to 10 times full. So that's why this isn't going to happen anytime soon. Okay. Then airborne laser is another program that's currently running at about $600 to $800 million per year, and is proposed to increase greatly. Already $5 billion have been spent on it. And the idea is you have some targeting lasers and a high-powered laser in the nose here, and you fly near North Korea and you shoot at the missile as it rises above the atmosphere with a high-powered laser beam, which would make a hole in it or soften it so that it fails structurally. And so this is one of the missile defense concepts that's being pursued. It's having some troubles. So I think there's a very real possibility it will be canceled within next year. In the discussion, I could go into that. But basically, many of the major system components have not been able to be built or have failed when they were built and tested. And it also has a fairly short range. It would have a range, decent range, 600 kilometers against liquid-propellant missiles, but only 300 against solid. So what does that mean? So even out of a small country like North Korea, the airplane has to fly in this area. Okay, and this is North Korea, folks. This is China. So we'd have to have some cooperation to do that. Or people say, well, we could suppress the intercept capability of North Korea, which means go in and destroy all the Air Force and the interceptor missiles and everything. Well, that's a whole other game. In Iran, you're hosed. There's nothing you can do because Iran's so big. You can't get anywhere near where you want to be. Unless, again, you fly, these planes are slow-flying, huge targets, cost $5 billion or $3 billion a piece. And, and you're going to fly them over, hostile territory where a SAM, it costs, $10 million to take it down. Oh, sorry. Yes. Was there a question there? Oh, yeah. An excellent question. So that is impossible. Okay? So you have to hit it while it's still attached to the missile, which is fragile. And you have to hit the missile while it's still in powered flight because it's under competitive loads when it's accelerating. But by the time it stops burning, then even though it's relatively fragile, it won't be seriously damaged if you hit it then. So you have to get it within the first couple of minutes while it's still in powered flight. So, but I think I know why you were thinking earlier about this. So I said as it rises up out of the atmosphere, yeah, that's probably what I didn't make clear. So the laser beam can't propagate any distance in dense air like near the ground. Okay, so they won't work until the missile gets really above the sensible atmosphere. But you have to get it before the warhead is released, so you have a narrow window of opportunity. Does that make sense? Okay, great. Thank you. But there are a lot of other people who I've confused as well, so thanks very much. Okay, well, there are other issues. I will skip over this because I want to come to some general things at the very end, but just mention that munitions from North Korean missiles, if there was a successful intercept, would have a high probability of impacting on Russia or Canada. So this is something to think about. Munitions of the intercepted missiles coming out of Iran would impact Western Europe, potentially. They're not incredibly excited about, enthusiastic about having such a system. Okay, so what is the proper role for missile defense? Just a couple of words here. I think that, as we've said, all the experts agree this is not the most serious threat. The most serious threat, I think, is twofold. That due to nuclear proliferation and that due to nuclear those are the kind of things that could devastate our country. And the situation is getting worse. The governments unfriendly to the U.S. are increasingly trading with one another to obtain nuclear weapons. I could go into this in detail, but I'm not right now. To answer your questions privately. Nuclear weapon materials and technology are increasingly being proliferated by private networks, like the AQCOM network based in Pakistan. This is something, a completely new phenomenon within the last 10 years. It's an enormous impact. There's stuff floating around that just makes you lie awake at night that got out because of this kind of activity. And what is stunning to me is the U.S. is failing to take readily available theft, diversion, and sale of nuclear weapon materials and technologies. An example, we have a program called Non-Lugar, in which we agreed to buy that nuclear weapon material at below the going price or equal to the going price. This is stuff you put it together and blow it up. So we agreed to do that, but the Congress decided, we don't want the government, the U.S. government, to do this. It should be pressed. And we're spending $10 billion on something that we aren't sure would ever work. I can tell you, if we get that stuff and we lock it up, it's not going to be coming at us in a war. I guarantee it. Okay? And it's so easy to do. So what are we thinking? What are we thinking? Theft, diversion, and sale of nuclear materials, and the leak out of all this stuff also increases the danger of non-state actors gaining nuclear weapons and leading to nuclear terrorism. So I'll skip over this video, but basically this General Eugene Hubbard talked about that was the most important threat that we should be focused on. And when he was Commander-in-Chief of U.S. Strategic Command, he said in this video, he said, I did not lie awake one moment worrying about missiles coming at us. I lay awake night after night worried about nuclear weapons delivered by riding trucks or barges or sneak into the country. He said, that's what I'm worried about. And that's true of almost all the people who are knowledgeable. So, here's a cartoon that kind of, I think, captures one aspect of this. It's not necessarily bad that we're thinking about missile defense, but we should look over our shoulder. This may not be, I think we're taking our eye off the ball. Okay? We really should be paying attention to the most serious, urgent, near-term threat. And there's time to deal with this other threat of missiles in many different ways. But the nuclear terrorist threat, the proliferation threat, is today. And if we continue, this is my conclusion, if we continue on our current path, it is inevitable that a nuclear bomb will explode in the center of an American city, and maybe within 10 years. It is a guaranteed outcome. Our failure to take actions necessary to prevent this, I think, is inexcusable, because there are many things we can do. It's not impossible, okay? So, but I just tell you that, this is the size of the amount of plutonium that you need to make a nuclear bomb the size of the one that destroyed Hiroshima, well, that was in Nagasaki, the plutonium bomb, okay? It's this big. Now, it's not as light as a baseball. It would weigh 25 pounds, but hey, I can put this in my bag over there, okay? So now, by letting this stuff leak out, we've made things much worse. But without this, you can't do anything. So if it were up to me, I would point every effort on getting control of this stuff and locking it up. We don't, Britain doesn't let the Queen's jewels get stolen. We have some gold left in Fort Knox. We don't let people break in and steal that. What the heck are we doing letting this stuff? I mean, if gold gets away, it's costly, but it's not going to destroy our country. If this stuff gets away, it could destroy our country. So anyway, that's where I think we should be putting our efforts. Thank you.